So this is going to be a tutorial about creating a water splash along a curve such that you can animate it and turn it into whatever kind of water you want, or whatever kind of liquid. You'll be able to adjust the size using the radius of the points. And yeah, let's just jump right into this. Blender 3.1 beta. I will go ahead and spawn in a Bezier curve. Then I'm going to geometry nodes to give a new geometry node setup inside the geometry nodes editor. It will help out in our modifiers tab, you'll see that. And let's just give this thing a little bit of depth using a curve to mesh node. So to the curve to mesh node, I would just give a curve line as the profile curve, and we'll see what that does. Is it does this weird thing, because technically this curve line is not aligned to the center of the world. It's poking up on the y-axis. We basically want to have it such that the start is minus 0.5 and the end is 0.5, so it's exactly 1 meter and basically centered on the world, giving us a proper ribbon along our curve to mesh. And then we also want to resample our initial curve because it currently does not have enough points. So resample curve, I'll resample based on the length and something like 0.1. Now if I seriously increase this length like 0.01, you're going to notice a bunch of defects happening over here. This is because of the way Blender previews curves. Just go into the object data properties of the curves and bring up the resolution preview to the maximum, and that will iron those out. I'll go ahead and lower that back again. And how are we actually going to get this to look like a splash? Well, we want it to taper off in the ends, and to do that we will use the spline parameter. The spline parameter has a factor value, which for every curve just gives a value from 0 to 1 at the start and end. So in the middle it will be like 0.5, and if I plot this out, the factor in relation to the length, it will just be a linear correlation, which is why if I use set curve radius, and the curve radius is how the curve to mesh actually decides on how to turn this into a mesh. If I just plug the factor in directly, you see you get a 0 to 1 value. And we basically want to transform that a little bit. The easiest way is just to use a float curve, when we can just plug this into here and then turn any 0 to 1 transformation into whatever curve we really want, just like that. So that is one way to do it. You can actually get some very special shapes like that, so it's more like tapered off in the end. You can really play around with this. Another way to get it is to use like a formula. For example, if I look at the linear transformation that we have at the start, and if I just give it a second power, that will be a parabola. If I up the minus, that will flip it, and then if I add one more x, that will actually give us a pretty smooth 0 to 1 transformation as well. So definitely play around with this. I'm just going to do it with the formula for now. Just you can see how that would work. Just plug in a math node, set that to power, then multiply -1 just to flip it, and then add to that the initial factor. And then of course in the end we want one more thing in order to actually multiply this by a random value, or rather just to set the maximum. However, for this thing what I like to use is actually the radius, because this is the curve's radius. Every point of the curve has a radius. Currently I only have 2 points, so with both points selected I will right click and subdivide, giving me a point in the middle. And then if I press N, or rather T, I have this radius tool, which will allow me to actually adjust the radius interactively in my viewport. Alternatively, I can press Alt S to achieve the same result. Alright, so other than this, let's talk about what we can actually do. We can actually resample this curve we're using for the profile based on a count. Rather resample it based on a count, which would let me just dictate the number of polygons along the width, like yeah. So next let's talk about imperfections. For example, I want to punch a bunch of holes into this surface, just make it a bit irregular. To do that I would just delete some geometry. You could do it with booleans, but I found that deleting geometry works a bit better. Basically what I'm going to use for this is a Voronoi texture. If I just plug that into the distance, well, maybe first we'll talk a little bit about what a Voronoi texture actually is, and for that I'll just spawn in a plane, and inside my shading I will just give it a quick texture, which will just be a Voronoi texture. And if I plug that in, you see that it is just a bunch of points in space. If I set it to smooth F1, it will smoothen those out. So the dark is a value of 0, the white is a value of 1. So you can already see if I just pass this through a math node that is set to less than, that will actually give us this very interesting sharp cutoff between these points, and the scale will just be the number of points we have, while the threshold is their size. So that's how you can think about this. And we're going to do this exact thing on our geometry node setup, where we're just going to take our Voronoi texture, plug that through a math node set to less than, and that's what's going to be deleting our geometry. Now you can see we are deleting, however there's these weird edges that are left here. That's because we're deleting on point. We basically want to delete on face, and also we need a lot more resolution. So to get a lot more resolution, I'm going to seriously bump up the resample count on the width, so set 64, and reduce the length resample over here, and now we can start to see our holes. I'll probably lower the scale just so we can get less of them. Maybe I'll lower it even more, and if I set this to 4D, I'll be able to change the W as well. I'm holding shift to make it move smoother, and you can see how we're getting our holes inside the geometry. So if I bring out a picture of water, you see that in reality it has this thick edge, a thick rim on the edges, and to recreate that I just need to isolate this edge somehow. To do that, what I'm going to do is I'm going to isolate this edge and simultaneously turn it into a curve. So there is a mesh to curve node which does exactly that, and it takes in a selection. If I just plug it in, it will turn all the edges into curves. What I have then is the edge neighbor, and the edge neighbor actually gives me the faces that are connected to each edge. For example, this edge here, all the edges outside only have one face, while all the other edges have at least two. So I can just make a little rule here saying if the edges are less than 2, this is what I want you to turn into a curve. Essentially that will give us the outline of our shape. And then what I can do is, if I combine this with my initial geometry using a joint geometry, I'll be able to see both this and the curve on the outside. But the cool thing then is that since I have this curve, I can turn it back into a mesh, so a curve to mesh, and I'll give it a circle profile. So circle, curve circle for the profile, and I will reduce the radius quite a bit, something that we can actually see, and the resolution does not need to be this high. I'll set it to 8, and that's how we're going to get that thick outline. Now it's very jagged because we don't have enough resolution. You can bump the resolution up in the end such that when you're rendering it's actually higher than your viewport. I'll show you how to do that real quickly, just for one of them. For the input curve, for example, you can use a switch and is viewport node. So the viewport node returns a value of true or a number 1 whenever we are in the viewport. And then I can just set this to be, well, actually let's do this on the curve for the width first, which is this resample curve. And what I can do is, if I get a group input as well, so that I can plug this count out, then I will have it in my modifiers tab, is I can instead say, okay, whenever we are in the viewport, whenever this is true, I want you to use the count here. However, you do need to set this to an integer. Set the two options to integer. Whenever this is true, we are using that. But whenever we are not in the viewport, for example, you need to hook that up, you can just double that amount. So just take this amount, multiply it by 2, and that will really give you a lot more resolution. So that is one way. You can do that for this resample and for this resample. And one way to fix this, however, just so it doesn't look so jagged, in here we will actually resample this curve. And I'll resample it based on length and something pretty small, like 3, for example. I mean smaller, like 5. You can see as I'm decreasing this value, we are actually getting closer to hugging the actual shape of our mesh. However, we're also getting a lot of those imperfections, so I wouldn't go too low. The issue is, if I go to my W and I find a particular W where we have very sharp edges, then what you could see is sometimes this geometry underneath could poke through these edges. It's not happening here, but basically you want to keep the number for the resample of the edge curve as low as possible. Okay, so what else do we actually want to talk about? This edge is actually not that perfect. It's not quite as uniform. See, it's thicker here and over here, but it's not quite as thick on other places. So to do that, we'll again play a little bit with the radius of the curve. So again, a set radius. However, this will be after the mesh to curve. And for this, I will just use a noise texture, more specifically the factor of the noise texture right here. And I will reduce the detail and roughness, And then if I just plug that into a matte node, I will be able to actually scale it, because by default it's just a 0 to 1 transformation. I will reset the radius of the curved circle so that I know that this number here actually represents the radius of my curve. And you'll see that it looks fine, however some of the areas are way too tiny. Like here, for example, this is a bit more pinched than I want perhaps. So in these cases I actually want to use the map range instead, which will let me bump up, which will control not only the maximum value, but also the minimum with this to minimum. So I can make sure it's not too small. I'll just play around with these for a bit, probably bump up the scale a little bit. I'm hiding the viewport with this button, by the way. I just have a shortcut for it. Maybe I will bump this up after all a little bit, and yeah, this is okay. So this is basically our curve. However, our surface is still flat. It is just still a flat thing. Well, if we do look at this with a cross section, we would actually see something like that, right? And that is an issue. So to do that, I'll just take this geometry here and I'll just extrude it. I will extrude it along the normal with a very small amount, something like 0.01. Maybe I want to see only that surface right now, so I'll hide the curve, not individual, definitely. And I'll get a thickness that I am happy with. I'm not quite happy with this one. We'll lower it a little bit more, maybe even more. However, there is no button, so to fix that, I'm just going to join it with the original geometry. So join geometry with this one over here, just like that. Now it's double-sided. However, I don't really need these faces on the side, so I will just delete them really quickly. I think they can actually mess up the shading a little bit, and I already have a selection from them. It's this side thing, just plug that in, and now I just have these two layers, which is what I'm really looking for. However, if I combine this with the original geometry, we'll see that our edge here is actually slightly offset, right? Yeah, you can see it's a bit bulging out too much here, while over here it's not enough. That is because when we extrude, we actually pushed everything in a single direction. So to fix that, I'm just going to use a set position before I do the actual extrusion. And what I'm going to do is I'm going to move everything along the normals, and in order to control how much I'm moving it along the normals, because by default the normals are 1 meter long, I'll just scale this vector. And what I need to do is I need to offset it with an amount that's equal to half of this. So I'll just plug that into the scale, and also in the opposite direction, so minus this and divide by 2. And what that would do is, because the extrude mesh already extrudes by the normals, I just moved it preemptively back with half of this amount, so that we're not really offsetting our edge quite as much. One more thing you're gonna notice is if you go over here and click face orientation, red means the faces are flipped, and they're flipped on the bottom, which is because we used the original face here. Basically just get a flip faces node, and that will fix up that shading issue for us as well. Alright, so currently the surface is a bit too perfect for my liking, and also this edge is a bit jaggy. So to fix the edge, first of all, it's very simple, just a subdivide surface, which will soften that up for us. No more than one, really. There we go. And this, you see there are these imperfections here. They're because we didn't have enough resolution at the start. Again, in the final render you would have more, so this wouldn't be an issue really. Enough resolution over here for the curves. And also when you do bump up the resolution for the curves, you also want to increase the resample for the edge curve as well. I mean decrease it to get more samples. Alright, so let's talk about imperfection, because this is currently a bit too flat, a bit too perfect. That is actually very easy fix. Just after the delete geometry node, I'm going to plug in a set position, which will feed into the other two set positions, and this will give us a noise using a noise texture. However, if you want to use the color, we want to plug that through a vector mat in order to subtract 0.5 in order to center the RGBs on the world, so that they function like vectors. And then one more node in order to actually be able to control the boost of that, and then I'll plug that into offset. It will be too strong, no detail, no roughness, and I will reduce this as much as I feel looks decent. Feel free to, of course, play around with this. That looks fine to me. And I'll probably leave it at this. Of course, we also want to set a material so that when we go into our shader preview, it actually looks like a liquid. So after everything has been done here, just set material node, and what I'm going to use is I'll create one right here. I'll call it one, and I'll just give it no roughness, and maximum transmission. And also at the very bottom we want to give it screen space reflections, and in the render settings for Eevee, no viewport denoising, because it just looks a bit better, and then screen space reflections, so we can actually see those refractions as well. And now if I just set that up over here in the geometry nodes, we will see that thing. However, I do also want to see my HDRI, so I'll add one in HDRI really quickly. It is just an environment texture. And then I need to go into the final render mode. See, this is a very dark HDRI, so I'll bump it up quite a bit. And there we go, we're getting pretty close to a water. And of course, if you are looking for a more like inky, like the ink I showed at the start, just maximum darkness and no transmission will probably work just fine for you. One issue is that the edge here will be kind of sharp, because it's supposed to be like this, but what we have is this situation. Now there's no easy way to fix that, so we're just going to cheat a little bit while going in the shader editor. What I'm going to do is I'm just going to add a bevel node, which basically looks at the normals of your surface, and if the transition between them is too sharp, it just softens that up. So basically this is like a fake soften up. However, this does only work in cycles, which is a bit of a bummer, but if you're looking for physically accurate refractions, you're probably using cycles anyway. So I'll set this up to GPU, and light paths I'll set to fast GI approximation, so it can render a bit faster. And then I can start to play around with this value a little bit until we have softened that up. So increase the samples for a bit higher quality. You can see it softens that up. I'm pressing M to mute it. It's a bit too high, I'll lower it a little bit. There we go. So that is how you can get a much nicer result, I think. However, I will just continue on with Eevee for now. And one crucial element we're missing are the droplets that are going. Technically, if you look at it, they're kind of at the edges because they're splitting off from the edges. So we want to get droplets on the edge. In order to do that, well, we already have a curve that is on the edge, right? So I'm going to use that curve combined with an instance on points, because the curve is technically just made out of points. So that would be before I turn it into a mesh. These are going to be my points. And before the joint geometry, if I plug that out and I give it something to instance, like an icosphere, I'll just plug this into the instance socket. It will be too huge, so I will also scale instances a little bit. And I basically want a random scale, so I'll get just a random value right here. I'll plug that into the scale, and then I'll reduce the minimum a little bit. There we go. Now we're getting something that looks like droplets. They look very sharp because before I instance them, I want to go shade smooth, set shade smooth to true, which will help. You can bump up the resolution, of course, but I really don't think that's necessary right now. I will reduce the radius a little bit more. Currently they're all overlapping at the center, and what we want to do is we want to move them away from our surface, like on the edge. Now, how are we actually going to do that? If you look at our surface or a situation right now from above, you're going to notice the following thing. This is our surface, and if I take the normals of the surface, they will basically be pointing towards me. Like, imagine this is an arrow that's looking towards me. And this is our curve that we create at the edges. Now every curve has a thing called a tangent, which is just a vector going along the length towards the end of the curve at every point, right? So I can actually use this normal here and this tangent to get a new vector. Because if I have two vectors, right, that are on a flat plane and I get their cross product, that's a third vector that is perpendicular to both of them. Right, and then I can get the normal and the tangents cross product. Like, imagine the tangent is over here. A vector perpendicular to those two would be in this direction, right, or in this direction, which depends on how you get the cross product, because the cross product of A and B, which is denoted like this, is it's not equal to the cross product of B and A. And the difference is exactly in the direction of this new vector, whether it will be facing towards me or towards the screen. So in order to actually get this normal information into our curve, because the curve is no longer really a surface, it doesn't technically have normals, we need to use the capture attribute node. Now the capture attribute node stores information inside our geometry. So what I can do is, before I went mesh to curve, I can actually capture a vector inside this, and that vector will be just my normals. and then I will have access to these normals later on. So let's go ahead and get the cross product of this normal information and our tangent. So get the cross product, get the curve tangent, and in order to actually use this I need to align my icospheres with that direction. So there is a note for that, align Euler to vector. This is the vector I want to align. I want the Z to be aligned and plug that into rotations. So next up, if before I scale I go translate instances and I move them on the Z, you should see that they are moving out, right? They're moving away from the edges the way we expected. However, I want a positive transformation to mean that they're going out, so I would need to flip this vector like I talked over here just by changing the direction of the cross product. Also, I want to randomize this, so that would be another random value. However, I only want to randomize the Z, not all three values, so I would need to separate that using a combine XYZ, plug this into Z, and then plug it into the translation. So now I can set a minimum and a maximum value so that they look fairly random at the edges. However, they are still aligned because this third vector we got is still flat, technically always away, so we want to give this a little bit of variation. To do that, we will take this cross product and plug it through another vector mat, or rather we'll plug it through a rotate vector rotate, which means we can take this vector and rotate it around another vector, and this another vector will just be a random value set to vector. In order to get every possible direction, we actually want the minimum to be -1. So that will be our axis, and then the angle would be the amount of variation. You can see that as I increase that, they start to vary more at the edges, so something like this looks decent to me. And now if I go into the shader preview, we can sort of see we have our droplets at the edges. I would probably push them out a little bit more, just so they look a bit more random, a bit more interesting. And there we go. This is basically it for the static shot. For example, if you go into edit mode of your curve, now you can go into your draw tool and you can start drawing as many of these out as you want. You can see they're fairly performant even though the geometry is a bit dense. But again, I told you how you can use a switch to control the geometry in your viewport to lower it compared to your final render. And let's talk a little bit about animation. Currently it would be very easy, right at the very start, before I resample. It doesn't matter if it's before or after. If I just go trim curve and based on a factor, and then if I draw a slightly bigger curve, give me a second to do that. So I'll disable the modifier temporarily. I'll hide this for a second, go into edit mode. By the way, this is PureRef, very cool program. It's free, you can just Google PureRef. It's just a little image that's always on top of everything, and I really like that. Alright, anyway, so in order to add more points, I'll just delete this one and start pressing E in order to get, I don't know, some sort of shape going. And in order to smooth them, I'll select them with a right click, set handle type automatic, which will just kind of smooth that path up. And now if I re-enable this, you'll see my entire curve. However, what I need to do is plug out the trim curves parameters, so the start and the end, we need to plug those out, go back into here, and I will just change the end to 0.1. You can see how that just changes the side, and I will keep both of these with I. I'll go to the last frame, I'll set the end to Y, key that, set the start to 0.9, key that as well, and now what I should see is basically it's going along curve. There we go, just like we wanted. However, it is looking a bit weird, which might be because I do need to resample before I trim. Let me check if that is the case. Yes, that is way smoother. Okay, so you do need to resample before you trim. Anyway, what are some of the issues with this? Well, you can see my noise is staying put in space. I kind of want it to be a bit more animated. I also think it's a bit too big right now. So I would just change the threshold if I can see my mesh. Yeah, something like that, because I don't actually want them to be actual cutoffs right here. In order to animate it, I just need to use this W, right? So what I'm going to do, instead of keying that, because you could key that, I'm just going to get the scene time and hook up these seconds into here. And if I go into a frame that has cutoffs, you see how now they're also moving in space. I think they're moving a bit too fast. In order to control that, I'll just plug this through a math node set to multiply, and then if I just get 0.5, that will be half the speed, so they won't be moving as much. And yeah, you can see that now they're very nicely animated. They're still getting cutoffs here. You just need to lower this threshold until it can no longer actually be big enough to cut through the geometry. Or you can just increase the resolution of all your points, either from setting it manually or right over here before you plug in the resolution, just another modifier to control that globally, sort of, in quotation marks, globally of course. Yep, just play around with this. Now they're animated and I'm pretty happy with this result. However, one thing you'll notice is that the droplets, they kind of look weird. They're really tiny, you can see them. Maybe just to preview them, I'll bump them up. Over here in the scale, just increase the maximum, and maybe I'll bring in the minimum a little bit just so you can see most of them. Maybe not that much, something more decent. Also, how do you change the count of these particles? Because currently it depends on the resolution of your curve. That isn't really nice, so I'll just resample one more time based on count, okay? And then it will be completely independent of whatever resolution you actually picked for the final render. So that was a little important note right there. And the issue is that they're currently staying put in space. I don't really want that. I want them to kind of flow out, you know, like it's leaving a path behind. And the easiest way and most accurate way is to do this with particles. But curves don't have particles, so what I'm going to do is I'm just going to move this entire setup into an object, into a mesh. So first I'll rename my setup to Splash, and then in my main I will just add a plane, give it a geometry nodes modifier, which is, if I go into my geonodes, make sure I have the plane selected. These are the geonodes of the plane. I will just select Splash. And I would just click this button to duplicate that into its own unique node setup, and I will call this one Splash Animated. Okay. And what I need to change here is just this input. It doesn't have to be the plane, it has to be our object info, more specifically the Bezier curve that we used, and relative position, and that is the geometry we're going to be using. And now I no longer need this to actually have a modifier, so I'll hide that. And you can see the entirety of my plane, which however doesn't have those keyframes, so it's not really animated. So give me a second to redo those. Okay, there we go. And now what we can do is, instead of having particles here in the geonodes, I will just completely remove the particles from this setup, which are of course this instance on points and this whole thing. There we go. Now there should be no particles, and instead we're going to use the particle system of Blender, which is just these dots right here. Add a new particle system, and if I just play it now, they play from the center of the world. That's because it's not actually using the modifier stack, it's not acknowledging the geometry nodes. We just need to enable use modifier stack, and now it's flowing from everywhere. What I want to do is actually disable the gravity, so no gravity. That will make them flow out. They're a bit too... Well, first of all, they're too big because they don't really have an object. They're instancing these abstract spheres that don't really exist, so we want to give it an object. Go ahead and do mesh icosphere, just like that. Go ahead and give it a shade smooth, F2 to rename it to particle. And at this point you can start naming stuff, like this is particles, this is just the curve, I guess. And in the render, you can go into object, and you can select the particle, the single particle. And if I go into the shader preview and I just press play, yeah, now they're coming off. They're not textured because I actually need to add that texture to the actual particle. So I'll just pick it from this drop down water. There we go. Hide that, hide the original curve. Actually, the original curve can stay. It sort of gives us a path now because I did disable its modifier. It's just a path to my actual mesh object. The particles are clearly sticking around for way too long. To fix that inside the particle settings, I will just lower the lifetime to something like 20. That's much better. That's much better. By default, they're moving away because the velocity has a normal of 1, so it's moving the particles away from the normals with a value of 1. And if I change that to 2, it will basically fire them way further away. So you can play around with that as well. And this is really all of it. This is all I wanted to show you. You can also tilt the curve at any point using this tilt or just Control T to get even more interesting shapes for the static one, for example. I will be uploading this to my Gumroad, probably in 2 separate scenes with the animated and the static version, because in the static version it's just a single object, so it's more convenient. That is until Geometry Nodes decides to add particles, because I hear that that's eventually coming. But until then, please subscribe, leave a comment, like, and yeah, I'll see you next time.